Okay, wanted to make this video. As you can probably tell, I'm recovering from a cold. So hopefully you can hear me all right. Thank you for subscribing, and sorry for slacking on the videos. Today I want to cover the formula. That is, I want to derive actually the formula for an increasing annuity, okay, where the first payment is P and payments increase by Q. Okay, this is what is referred to as an arithmetic progression regarding the payments. Because the payments, as you can see here, just focus on the top timeline. I'm starting with P, and each year you can think of it as basically receiving Q more dollars than the previous, right? So my first payment maybe for my annuity is P, and then it's P plus Q, P plus 2Q. So as you can see, the payments are increasing arithmetically, okay? Because the common difference is 1. Or sorry, the common difference is Q. They're increasing by Q, right? All the way up to the nth year, where I have Q is increased by n minus 1. So not too much going on right now. Now I want you to focus on the second line. The second line here is actually equivalent, right? Because now all I'm saying here is that my first payment is P, and then it's P plus Q, and then it's P plus Q plus Q, right? Namely, P plus 2Q. Continue down the line, and how many Q's do I have here? I have n minus 2 Q's and then n minus 1 Q's. So why would I be writing it this way? Well, let me explain that. If you've studied for exam FM, you know, well, hopefully you're familiar with this sort of technique. This can be useful for evaluating specific types of annuities which may be level for a while and then change. So looking at what I have here, hopefully you can agree first of all that these are representing the exact same thing. I'm just thinking of it a different way here in the second timeline. So what am I going to do with this? Okay, I'm just going to compute the present value of this increasing annuity, where the first payment is P and it's increasing by Q. I have to specify that because an increasing annuity specifically is where the payments start at 1 and increase by 1. So I'm going to get to that example. This PQ formula, a lot of times for short, she's called the PQ formula. The reason why I want to do this is because pretty much 10, 15 other formulas come from this. If you're like me, you want to know where things come from. Now, I know a lot of people say for these exams, you know, just memorize, blah, blah, blah. You don't care about where it comes from. You don't care why it's true. Personally, if I can see why something is true, it will help me actually remember it. So I like to go through this sort of thing. So bear with me. What is the present value of this annuity? So present value. And again, I want to focus on the second timeline here. I want to just first focus on this portion. In other words, focus on the first bottom row. What's the present value of that? Well, that's easy. That's just a level annuity, right? With payments P. Okay, so this is, the payment is P, and this is an annuity immediate, because the first payment is made 1 year after time 0. And by the way, I'm evaluating here. I'm evaluating at time 0. So I'm going to bring everything back to time 0. So this is P. Since it's a annuity immediate, present value, it's A sub n angle n, right? I could put an I here for the interest rate, but in terms of deriving this formula, we're not concerned with the interest rate whatsoever. So I just have this. All right, so I've taken care of the bottom row. Taking care of the bottom row. Now I want you to focus on the second row. the second row, now my payments are Q. And I want to compute the present value of this. So this is going to be plus, okay? My payments now are Q. All right, well, how many do I have? Well, here there were n payments, and this is one less. So this must be n minus 1 payments. Now we need to add something here because, again, I'm thinking of this as an annuity immediate. Notice I don't have the double dot. Where does these payments get evaluated to? They get evaluated to time 1 right here. So I need to bring this back by 1. I'm going to put an exponent 1 there. Okay, I'm going to discount this back to time 0. So I need this discount factor here. Now I think you know what we're going to do next. Next thing I'm going to do is I'm going to look at the third row. So now look here at this row, and same idea. If I continue along this row, hopefully you can see that I'm still going to have the payment of Q, so I still have a payment of Q. How many payments of Q am I making? I'm making n minus 2. So n minus 2, forget about the interest rate. This is an annuity immediate, taking it here, but I need to discount it 2 years back. I need to discount it 2 years. So hopefully you're seeing the sort of pattern, because now I want to write this in general. This can be difficult to write in general because, I mean, it's in general, right? So focus on the index as well as the power. Notice that the index and the power of v always add to n. And here, in fact, if I had v to the 0, which is 1, it would add to n. These add to n. These add to n. That will help me figure out what I should put for this piece. Now, if I go all the way down to n minus 1, okay, I have all these q's up here, and that's what I'm dealing with, okay? My payment is going to be q again, all right? How many will I make? Well, just these two, this one and this one. So there's only 2 now. There's only 2 payments of q. Okay, so this gives me the annuity immediate for the value of those, bringing back to n minus 2. But now I need to take it all the way back to time 0. Now this is where the powers come into play, because these add to be n. If they need to add to be n, then this must be v to the n minus 2. 2 plus n minus 2 is n, so that looks good. One more to go. Now let's deal with this one. I'm only making 1 payment of q. All right, so 1 payment, and now I need to go back n minus 1. Same idea. The index of 1 and the power of v add to n. So it looks like we're in good shape. Well, we don't have the formula yet, so let's keep going. Now what I'm going to do is I'm going to factor out q. So factor out q. So my present value is now p an plus q. Factor the q out. What I'm also going to do is I'm going to use a definition of these different annuity immediates. So what is the definition of this annuity immediate here? Well, you know this is 1 minus v to the n minus 1 times v. So this is the v, goes here, and I have this. So this is over I, right? I'm just going to put, these are all going to be over I. So I'm going to put I in the denominator, okay? Now, what is the definition here? Same idea. So this is 1 minus v to the n minus 2 times v. Keep going. Finally, we'll get down here, and this is going to be 1 minus v squared v to the n minus 2. And you guessed it, ran out of room again. Damn it, I hate that. Let me just make it so that this will fit, because I absolutely cannot stand it when I run out of room. So let's give myself some more room here. Let me just rewrite it. present value, I have the p. I'm going to leave this. As you hopefully know, for the PQ formula, this is exactly what I want in the beginning. So I'll leave that. Factor the q out. Let's try that again. So this is 1 minus v to the n minus 1, v, plus 1 minus v to the n minus 2, v squared. Keep going. This is going to be 1 minus v squared, v to the n minus 2. I'm pretty much out of room again. How annoying. 1 minus v, v to the n minus 1. Man. So that's closed off there. Hopefully you can see that. If you can't see that, I leave those powers to you as an exercise. As you know, taking math classes, authors always love to write that. It's probably the most annoying thing ever, right? I leave the proof as an exercise. Really annoying. All right. This is where I want to be. And what I'm going to do now is just some basic algebra. Just going to distribute all of these powers of v. Okay, and I'll group those together. Let me show you what I mean. So now my present value is still p. And then I have my annuity immediate end payments plus q times, let's distribute these various powers of v. And hopefully you can see if I do some regrouping, this is what I have. I have v plus up to v to the n minus 1. So what I'm doing here, I'm distributing this. All right, distributing this. Keep going, keep going. And hopefully you can see that the highest power, when I distribute this v to the n minus 1 right here, I get to the n minus 1, right? Good, so looking at this, you should be saying, I mean, the part that's supposed to go here is an annuity immediate with end payments. This is not right. I mean, this is not quite right. But look what we can do. Distribute to this piece as well. We need to distribute here. This is minus v to the n. So v times this is v to the n. V squared times this is v to the n. So minus v to the n minus, keep going, v to the n all over I. Now, another counting argument. How many v to the n's do I have? I guess this isn't too bad because, I mean, we've already convinced, I mean, how many v to the n's do I have here? How many v's do I have? Remember how you count something like this. This is to the power 1. If I want to count these this number of items here, n minus 1 minus the previous. N minus 1 minus 0 is n minus 1. So n minus 1, which means there are also n minus 1 of these. So we're in good shape. And of course, not a room. So let me make some room. And we'll finish off this piece, this computation. And from this, we'll derive a whole bunch of other helpful annuities with payments and arithmetic progression. Okay, so let me show you what I mean. We're pretty much there. Just need to do a little bit of algebra. I want you to take this portion upstairs, right here. All right. Let's rewrite this. I pretty much have everything, right? So this is present value, the first payment of Q. Now I have an annuity immediate plus Q inside the brackets. I'm going to leave this as is. I'm going to do some manipulation here though. So this is parentheses V all the way up to V to the n minus 1. Here, well, there are n minus 1 of those. If I subtract something n minus 1 times, I mean, think about this. Hopefully this is not confusing at all. This is just minus n minus 1 to the v to the n all over I. All right. Does this look good? This absolutely looks perfect. This looks perfect because lo and behold, abracadabra, nothing up my sleeves, no magic involved, although it seems like magic. Distribute the negative, okay, that will become positive. Distribute the v to the n. What do I have here? This is v all the way up to v to the n minus n v to the n. Okay, so in a way, I guess I skipped some steps, but I'm not doing anything fancy. Distribute v to the n here, and bring this over to this series right here. This is exactly what I want. This is it. This is it. So, in conclusion, we absolutely have it all. We have everything. Well, regarding this problem, of course, we don't have it all in life. Maybe you do. All right, you know what I mean. So, this is what we have. We have our formula, the PQ formula, right? Because this is by definition an annuity immediate and payments. Well, payments of 1, annuity immediate, right? So AN minus NV to the N over I. Let me put brackets there. And this does it. This does it. Now, as I mentioned, many formulas come from this, specifically in this section. Let me just go through a couple of those. I don't want to go through too many. Let me just go through a couple. And there are several more I'm not going to go through. First one is I want you to take this formula and find the accumulated value. I want to think of it's the exact same arithmetic progression of payments. What I want to do is to sort of get this formula, just imagine how am I going to make this a accumulated value of a level annuity immediate. In other words, I want S sub n, well, S sub angle n, right? Well, hopefully you know that this is true. You should know that an times 1 plus I to the n. Think about this for a second. I'm just going to accumulate the present value n periods. That's exactly the accumulated value. That's exactly this. That's exactly Sn, right? So what am I going to do? I'm going to multiply all of this, multiply by 1 plus I to the n. Now we need to do this in a slightly clever way. Okay, I'm not going to blindly multiply to everything, but I'm going to multiply it to the numerator here, and then to this piece right here. So I multiply 1 plus I to the n times this, as I just mentioned. This is Sn. Q remains. Multiplied here, this is Sn. Minus, now what is 1 plus I to the n times v to the n? Well, those are reciprocals of each other, so that's 1. So this is n over I. Now we get the formula for the accumulated value. This is another important formula. Not too bad. Not too bad. Now, how would I get how would I get the present value with the double dots? How would I get the present value due? Present value due. Well, hopefully you know another important formula. That is, what's the relationship between a double dot angle n and a angle n? Well, it turns out, and this is a pretty easy argument to make, if I multiply a angle n times 1 plus I, that does it. So this is actually a angle n 1 plus I. if I just sort of bring everything forward one period, that gives me the annuity due, present value of annuity due. So, hopefully you see what I'm going to do then. I'm going to multiply everything by 1 plus I to the power 1. So this gives me the following. This is now a double dot n plus q. Up top, I'm actually going to leave it. Let me leave this. Okay, and over I still actually have, let me write it this way, 1 plus I. I multiply 1 plus I there. But yet another thing you should know, what is the discount rate? The discount rate is I over 1 plus I. Which means 1 plus I over I is D. Oh, how convenient is that? So let's get rid of this and just make this D. And there's our formula for the accumulated value, present value, payments in arithmetic progression, with the first payment beginning at time 0. So kind of like an annuity due. Now, let me do one more. How do I get the symbol parentheses I, A, angle N? In other words, how do I get just an increasing annuity? An increasing annuity present value. I want to, again, take this formula, let P equal 1, Q equal 1. What am I doing here? I'm taking, I want to find the present value. The first payment P is made at time 1, and each period after, the payments increase by 1. Replace P and Q with 1. This says that the present value is AN plus A angle N minus NV to the N over I. Let's find an LCD. Okay, so this means that present value is equal to I, A angle N plus A angle N minus NV to the N over I. Factor out A angle N. This is equal to A angle N, 1 plus I, minus NV to the N over I. What is this piece, though? We just discussed this. This is now an annuity due, right? So, but this guy, exactly, this is AN dot dot minus NV to the N over I. So, just sort of a conclusion there. What I'm saying is that the increasing annuity, a present value, right, is equal to this, A double dot minus NV to the N over I. Don't forget the fact that this is A double dot, easy to forget. This is my increasing annuity. You could also get decreasing annuity. You get all sorts of other business here, and it all stems from this, the PQ formula. In fact, most of the time I just want to memorize this, forget the rest. I mean, I can figure it out from this, right? Computations could be a bit more expensive, but that takes care of it. Tell me what you think. I hope this was helpful, and thank you for subscribing.